Believe it? Overnight, 700 mountains completely vanished, giving way to a vast plain ready for a megacity to be built upon it. This is not from a science fiction film. It is a significant event that is currently taking place in Lanzhou, China. An investment of 2.2 billion has made this terrain modification project one of the largest in modern engineering. The question is, how can humanity restructure the Earth's surface on such a terrifying scale and with such raw intensity? Is wiping out hundreds of mountains to serve urbanization ambitions a monumental leap in engineering or a reckless gamble with our geological ecosystem? In today's video, Massive Minds takes you inside the Lanzhou mega project where mountain peaks are erased to pave the way for human ambition. The project, known as the Lanzhou New Area in Gansu Province, operates on a staggering budget of 2.2 billion. Its scope goes far beyond just constructing a few buildings. It aims to carve out 25,000 acres of entirely new land from a landscape once defined by rugged, unforgiving peaks. To truly grasp the magnitude of this undertaking, we must look at the geological reality of Gansu. This is a brutal environment, dominated by massive loess mountains hundreds of meters high. The soil is prone to collapse, and water is scarce, making every day of construction a battle against the harshness of nature. Faced with such complex terrain, planners did not hesitate to discard the mountain-conforming approach, a method used successfully in Chongqing. Instead, they opted for the flattening model. Though a far bolder and more expensive path, the long-term vision is to create a tabula rasa, an absolutely flat geological plain that offers massive potential for future exploitation. But the question remains, how exactly do you move Sepsense mountains? To solve this massive puzzle, engineers don't just move dirt, they harness a core strategy known as cut and fill. This is a rigorous mathematical operation on a scale of billions of cubic meters, where every bucket of earth scooped from a mountain peak already has a predetermined coordinate in the deep valleys below. This principle effectively strikes the word waste from the project's vocabulary. Instead of the massive cost of hauling soil away, the entire volume of earth is repurposed to restructure the terrain on site. Optimizing the routes for thousands of dump trucks isn't just about saving fuel, it is a vital lifeline for keeping a 25,000-acre mega project on schedule. However, as the valleys are filled, a new physical nightmare emerges from the very nature of the loess soil. The loess in Lanzhou possesses a treacherous technical trait, collapsibility. In its natural state, this soil has a porous structure with vertical capillary pores, making it incredibly rigid when dry, but causing it to dissolve and collapse instantly upon contact with water. Simply dumping soil to fill a valley would leave the city's foundation dangerously unstable, prone to warping after a heavy rain or a plumbing failure. To tame this, engineers must destroy the soil's original porous structure through a rigorous re-engineering process. The loess is excavated, crushed, and subjected to a meticulous, layer-by-layer recompaction. The goal is to eliminate every capillary void, transforming a spongy and unstable geological material into a dense, solid foundation, with a compressive strength that far exceeds its original state. This mountain-moving process is, in reality, a total geological overhaul where humans dismantle nature and reassemble it in a controlled order. But creating a flat surface is only the beginning. Filling valleys, hundreds of meters deep, brings another technical risk: differential settlement, a force capable of snapping any high-rise building placed upon it. To place hundreds of high-rise buildings atop this newly filled artificial soil, engineers face a grueling challenge in soil mechanics. How do you ensure the ground doesn't deform under tens of thousands of tons of weight? In Lanzhou, the foundation treatment process allows for zero error, as a single oversight in compaction could trigger structural disasters in the years to come. The first decisive technical choice is the compaction strategy. Instead of relying on dynamic compaction dropping massive weights from great heights, which makes it difficult to control uniformity in deeper soil layers, the project prioritizes layered compaction. The earth is spread in thin layers, just 30 to 50 centimeters thick. In each layer, moisture is optimized before sheep's foot rollers are deployed. The steel spikes on these wheels do more than just press down. They create a kneading force that eliminates every air pocket and void, ensuring an absolute compaction coefficient for every single layer. However, the greatest threat isn't the overall density, but differential settlement. On the Lanzhou site, some buildings sit right on the boundary between the original rock mountain base, which is incredibly rigid, and a newly filled valley, which is prone to deformation. This difference in stiffness is like placing one foot on a rock and the other on a mattress. The building would be torn apart by uneven stress. To neutralize this risk, preloading is implemented. Massive mounds of earth are piled high at vulnerable locations, creating simulated pressure to force the settlement process to happen immediately. Only after the ground has stabilized and reached its predicted settlement is the preload removed to begin construction. For skyscrapers requiring even higher safety standards, engineers utilize hybrid piles friction combined with end bearing. Giant drills penetrate the artificial fill, anchoring deep into the bedrock at the bottom of the former valleys. At this point, the building is no longer floating on filled soil, but is firmly tethered to the Earth's crust. These piles utilize both skin friction within the artificial soil and the solid end-bearing support on the rock to redistribute the entire weight of the superstructure. With the foundation locked in place, the Lanzhou megacity begins to take shape. But for a city to function reliably on such a massive artificial landscape, how must the underground arteries be designed to be both sustainable and non-disruptive to this sensitive geological structure? Installing infrastructure on such a massive man-made plateau requires technical solutions that account for the long-term shifts in soil mechanics. In Lanzhou, the stability of the entire urban system depends on preserving the integrity of the compacted soil, leading to the deployment of engineering systems that differ fundamentally from those of traditional cities. One of the most dangerous variables for filled soil is human intervention through excavation. In typical cities, repairing power cables or water pipes often involves digging up roads. In Lanzhou, however, this is viewed as a major technical risk. Once the soil structure has reached its maximum design density, any breach of the surface weakens its load-bearing capacity and creates pathways for air and moisture to infiltrate the foundation core. Consequently, a common utility tunnel system was built to house the entire network of electricity, telecommunications, and water supply. Operational analysis shows that this system does more than just eliminate excavation. It allows for active leak detection, the leading cause of loess collapse within a sealed, concrete corridor. For artificial loess soil, water is not merely an environmental factor, it is an agent of structural deformation. Engineers have established an absolute moisture isolation strategy using high-strength geomembranes. These layers are spread beneath critical infrastructure zones, acting as an impenetrable barrier to prevent surface water from seeping into fill layers that reach tens of meters deep. Maintaining stable moisture levels within the ground is a prerequisite for ensuring that soil stress does not shift abruptly. Furthermore, surface drainage design must follow the principle of hydrodynamic energy dissipation. Instead of using vertical drop pipes, which create high flow velocities that lead to erosion and localized water pressure, engineers prioritize step drainage channels. This design breaks up the water's fall height, reducing its velocity and kinetic energy before directing it away from the urban perimeter. This is the primary defense against surface soil washout, protecting the slope stability of the man-made plateau from the risk of landslides. Evaluating the success of the Lanzhou megaproject cannot be based solely on the appearance of the skyscrapers, but must be based on the balance between economic surplus value and environmental consequences. From an economic perspective, the project has achieved its goal of transforming dead land on the Loess Plateau into a vital link within the Belt and Road Initiative. By creating 25,000 acres of seamless flat terrain, Lanzhou has broken the spatial deadlock of its old city, attracting a surge of heavy industrial conglomerates and multimodal logistics hubs. Urban planning analysis shows that this concentrated megacity model allows for supply chain optimization, with inner-city transport costs significantly lower than in cities divided by rugged terrain. However, the cost of sculpting 700 mountains is clearly visible in environmental monitoring data. The widespread destruction of the surface structure has increased soil erosion rates by 10%. Because loess soil becomes fragmented when mechanically disturbed, fine dust has become the most pressing issue. Statistics show that PM2.5 concentrations in the air have surged by 49% since the mega construction site began operations. The permanent alteration of the landscape has also deformed the natural hydrological system. By leveling mountain peaks and filling valleys, the natural drainage networks formed over millions of years have been wiped out. This forces humanity to rely on expensive, man-made systems to maintain the stability of the ground. 10 years later, the skyline of a modern megacity has officially risen from the dust where mountain peaks once stood. From sprawling highways and high-tech industrial hubs to towering residential blocks, the new Lanzhou has become a monument to what extreme engineering can achieve when pushed to its absolute limit. But its future is not yet guaranteed. The city's survival depends on a constant, long-term battle against the geological risks we created, specifically the ever-present threat of soil collapse and the ongoing struggle with air quality. Lanzhou stands as a powerful testament to human ambition and our relentless drive to tame the earth. But it leaves us with a haunting question. Is an economic fortress built on the erasure of 700 mountains truly a sustainable blueprint for our future? Lanzhou's expansion is no isolated case. What we are seeing is part of a global arms race, where megacities are being backed into a corner by two relentless forces: harsh geographic boundaries and the insatiable pressure for economic growth. As the last patches of flat ground vanish, nations with suffocating population densities have no choice but to perform radical geological surgeries to carve out their own space for survival. While Lanzhou carves away at the mountain peaks, Singapore and Hong Kong have taken a different path. They confront the ocean head-on. Since gaining its independence, Singapore has pulled off an engineering miracle, blooming its territory by a staggering 25% through land reclamation. In the world of megacities, land is the new gold. When every square meter of these Asian tigers is valued at tens of thousands of dollars, the colossal expense of dredging billions of tons of sand or building massive seawalls isn't a luxury. It is a high-stakes investment with massive returns. But where Lanzhou's enemy is the collapsing loess soil, Singapore's nightmare lies in the unstable seabed muck, forced to bear the weight of civilization while facing crushing hydrostatic pressure and the looming threat of rising sea levels. To see a masterclass in combining the techniques of both Lanzhou and Singapore, you have to look at Kobe, Japan. With the Rocco Mountains project, Japanese engineers pulled off a bold maneuver that effectively killed two birds with one stone. They leveled the mountain ranges that were strangling the city's growth to create space for luxury residential districts. But they didn't stop there. Instead of worrying about where to dump millions of tons of excess debris, they turned waste into wealth by transporting that entire mass into the sea to build massive artificial islands like Port Island. This was the ultimate closed-loop geological supply chain. Mountain peaks were reborn as bustling urban centers, while their remains became the rock-solid foundation for world-class container ports. By squeezing value out of every single grain of sand, the project achieved record-breaking returns on investment, despite engineering challenges and costs that were nothing short of eye-watering. The Lanzhou megaproject is a testament to humanity's capacity to reshape the Earth. The demolition of 700 mountains was not merely an achievement in terms of the sheer volume of earth moved, but the result of rigorous soil mechanics calculations to create 25,000 acres of artificial land. This project represents a calculated strategic trade-off, a £2.2 billion investment in exchange for a flawless checkerboard logistics grid, while accepting the harsh reality of a 49% surge in fine dust and a natural hydrological landscape that has been altered forever. Lanzhou is living proof that when the physical Earth becomes a bottleneck for human progress, infrastructure engineering will step in to redefine the very boundaries of the natural world. What is your take on this forced terrain model of development? Do you believe the immediate economic gains can truly justify the long-term geological risks? We want to hear your perspective, so drop a comment down below to start the conversation. If you're fascinated by the extreme engineering behind the world's most magnificent wonders, make sure to hit like, subscribe, and turn on notifications so you never miss a deep dive with massive minds. Thank you for watching, and we'll see you at the next mega construction site.